Now we're going to talk about properties and changes of matter, and we categorize these by whether they're physical or chemical. So we'll talk about physical properties first. A physical property is a characteristic of matter that can be observed without changing the composition of the matter. So there are some examples there: odor, color, volume, physical state, density, melting point, boiling point. We can observe the color of this piece of paper without changing it. It's white and it has some black writing on it. That's a physical property. We could find the mass of it, or we could measure the length of it or the volume without changing what it is. That's the physical property. Chemical properties are a little different. When we observe a chemical property, the matter does change. The chemical property is a description of the substance's ability to form new substances. And so it is a characteristic that describes the behavior of the matter. Not what it looks like or how heavy it is, but how it acts. So a chemical property of this piece of paper is that it is flammable. If I had a Bic lighter and I lit this, it would burn. When I demonstrate the chemical property of the flammability of paper, do I have the paper left? No, the substance was changed into something else. So that's a chemical property. So examples include flammability, rusting, digesting your food. Anything that destroys the original substance is going to be a chemical property. So let's look at some examples. Classify each of these as a physical or a chemical property. And what you have to do when you're doing an exercise like this is ask yourself, well, is the substance changed by doing that? Ethyl alcohol boiling at 78 degrees Celsius. Does that cause the alcohol to change what it is? No, it doesn't. So maybe that's not obvious to you. I wouldn't expect it to be. What if we boil water? When we boil water, it goes into the gas state, but then it condenses back out of the gas state, and it's still water, isn't it? When something changes state, it does not change what it is. Whether it's in the solid, the liquid, or the gas, it's still the same substance. It's just that the particles are behaving towards each other differently, or they're separated from each other. So, like students, if you got up and started walking around the room, would you still be you? Yes. You'd be moving, and now we would say that students are in the liquid state because you're milling about, but that doesn't change who you are. Okay, so when we have a state change, when we describe something about a state change, like the melting point or the boiling point or anything like that, then that's a physical property. So ethyl alcohol boiling at 78 degrees is a physical property of ethyl alcohol. How about the hardness of a diamond? Diamonds are very hard. Physical or chemical? Physical. You can demonstrate that a diamond is hard without changing what it is. How about sugar fermenting to form ethyl alcohol? Chemical. So the clue there is to form. Here's a description of one thing changing into something else. That's a chemical property. So there are physical and chemical properties, and there are also physical and chemical changes. And they're really closely related. So sometimes we inadvertently, mix up a chemical change and a chemical property, or vice versa. And I'm not so concerned with whether you identify it as a property or as a change. It's the difference between chemical and physical that we're concerned about. So a physical change involves a change in the form of a substance, but not in its composition. So boiling or freezing water, that's a physical change, because the substance remains the same. The physical property is describing perhaps at what temperature that occurs. So the change in the property are very, very closely related. If I take a piece of wood and I saw it in half, is that a physical change or a chemical change? It's a physical change. I've changed the mass of that piece of wood by cutting it in half. I now have two pieces, but each piece is still wood. I didn't destroy the original substance. So let's re-examine those states. In all three states of matter, and sometimes they're called phases and states, we just kind of use those words interchangeably. In all three phases or states of water, the molecules are intact. And we've seen this picture before. But here we have these little molecules that look like little Mickey Mouse heads. And these molecules are the same as these molecules, as the same as these molecules. The difference is the motions and the distances between them. Just like students, when you are sitting here in the solid state in your little rows, you're fidgeting a little, you're moving a little bit. When we get up and walk around the classroom, now your velocity is greater, you're moving faster. But you're still pretty close together. When you leave the classroom, some of you go very slowly, some of you may go very quickly, but we separate apart from each other. So it's the spacing and the motion that describes the different states of matter, but the actual particles remain exactly the same. In a chemical change, the substance you start with becomes a new substance. That new substance is going to have different properties and a different composition. Chemical changes are the same as chemical reactions. So we also call these chemical reactions. So an example is a Bunsen burner. The Bunsen burner has methane reacting with oxygen to form carbon dioxide and water. So here is this gas changing. It's not just condensing or being compressed or something. It's actually changing into something else. And that's a chemical change, also known as a chemical reaction. And of course, we're going to talk a lot more about those in the future. So here's an example of a chemical change that water can undergo. And I believe you can actually do this just by dropping a 9-volt battery in a glass of water. If we pass electric current through water, we get bubbles here and bubbles here, these different electrodes. And what we're doing is we're decomposing the water. We're breaking the water molecules into hydrogen and oxygen. And it's no longer water. This is a chemical change, not a physical change. And what we end up with is oxygen gas and hydrogen gas. We have, here's illustration of that. So here's two water molecules. When we pass enough electric current through them, they come apart and they form hydrogen and oxygen. So the individual atoms haven't changed. It's a little bit like building with Legos. So here, we made these, of course, Legos aren't round like that. Let's see if I can do this. So here's my illustration of the Lego version of water. So you could make these funky little things. They're really simple, just 3 blocks and they're stuck together. And the electric current is Andrew coming in and messing with them. He's my just turned 5-year-old. And what happens? Are the atoms destroyed? No. But they're rearranged. They're taken apart and made into different things. And so now we're still going to have 4 of the small blue blocks, but they're not going to be stuck together with the red ones like they were before. Does that make sense? This is a chemical change. What we had here, all the particles of the water looked like this. They don't look like that anymore. It's not water anymore. Hydrogen and oxygen gases are flammable. Is water flammable? No, that's why we use it to put out fire. So the properties of the substance has changed because the substance itself has changed. Water is a liquid at room temperature. Hydrogen and oxygen are gases at room temperature. So how many of these are examples of a chemical change? Pulverizing rock salt, that just means crushing it. Is that a chemical change? No. Burning of wood, that's a chemical change. Dissolving sugar in water. Let's think about that. Well, if you put sugar in water and dissolve it, does the sugar still taste sweet in the water? Yeah, it does. And what do you think would happen if you let the water evaporate? The sugar would get left behind. We haven't talked about this at all in class yet, but when something dissolves in water, they're just mixing. It's like if you take flour and salt and you mix it together. Is there any reaction that occurs? You just have flour and salt mixed together. So something dissolving is just mixing. That's a physical change. How about melting a popsicle on a warm summer day? Melting. State change, right? That's physical. So only one of these is an example of chemical change. Any questions? We're going to practice this in lab a little bit too. Here's another one. Identify each as physical or chemical change. Sugar fermenting to form ethyl alcohol. Chemical. The clue there is to form. Iron metal melting. That's physical. The clue there, melting. That's the name of a state change. How about iron combining with oxygen to form rust? Chemical. To form. The iron and the oxygen become changed in that, and so it's chemical, not physical.